All right, good morning, class. So today we are going to be learning about object-oriented programming. So this is a really big concept, very important. It exists in many programming languages, and certainly it exists in both programming languages that we'll be using extensively in this course. But in this week, we're going to be focused mainly on Python. I think you'll just be challenged on your OOP skills in Python more than in JavaScript. And Python is a more conventional kind of object-oriented language. So that's what we're going to focus on at first. And then later on, towards the end of this unit on OOP, we're going to talk about how these same skills and concepts we've learned in Python object-oriented programming apply to JavaScript. But so for this week, focus mainly on Python. So like I was saying before, Python is an object-oriented language, which means in this case that everything is an object. So everything, booleans, strings, list, integers, everything under the hood is really an object. This is kind of the unifying system that Python uses just to represent everything. We'll understand this better as we dive into it. Now, objects. So objects have, say, attributes and methods. So now remember in our intro to programming conversation, I was talking about how programming languages are like spoken languages, talking about nouns and verbs, parts of speech and whatnot. So we're going to revisit that metaphor really quickly. If an object is like a noun, it's a thing. So it's a thing. It has attributes. Which are either adjectives describing something that the object is, or other nouns describing what the object has. And lastly, an object can have methods, which are verbs. These are things that the object can do. So these are kind of core concepts in object-oriented programming. We're going to create objects, and we care about their description, what they have, what they know, and what they can do. So it's very much about like coding with metaphors. I'm going to create objects that represent like dogs or people or cars or whatever. But we can't just, create objects just, as like independently. There is a step before that. We have to create classes which organize our objects. So a class in object-oriented programming is like a type of thing, or it's like a blueprint for a thing. So for example, we might have a class for dog or person or rectangle. Just some type of thing that we might have multiple instances of. So you might be kind of wondering why we care about object-oriented programming. Why are we adding these advanced concepts onto our code? Why are we trying to code in metaphors all of a sudden? You might think you already knew how to code, which just with functions and loops and variables, and that can accomplish everything you need to do. And while that is true, you can get the job done with just functions and loops, variables, dictionaries and lists, the things that you've learned already. There are a few useful benefits of object-oriented programming. So this is kind of classic, like 4 major benefits of object-oriented programming. If somebody asks you in an interview, like what's the point of OOP? These are kind of things that they're expecting you to list back to them. So encapsulation is an important benefit of OOP, meaning that we can restrict where data is accessible. So maybe there's a piece of data that is accessible only within a class, but not to other objects outside of that class. So an important concept in programming generally is whenever you declare a variable or create any kind of data, you need to make sure that it's only accessible where it's needed. That's why we don't make global variables as often as possible, because when you make a global variable, it's by definition accessible in many places where it's not needed. And it just increases the likelihood that it's going to get overwritten accidentally when it shouldn't have been. So OOP is going to help us restrict access to our variables so that they're only accessible as needed by the other code that needs them. Another important benefit of OOP is abstraction, which is maybe not a term that you've heard before, but it's something that programmers like to talk about a lot, something I'm going to be talking about a lot. It means that we are trying to hide some of the complexity of our program. So generally speaking, when you're writing a program, there are going to be a lot of complex ideas in play, lots of moving parts, and it can be kind of hard to think about everything all at the same time. So abstraction is the idea that we create one idea, one relatively simple idea that can stand in for multiple more complex ideas. And so this helps us think about our program differently, and is supposed to enable us to actually keep the entire program in our head at once and reason about what it's supposed to do, because we're not thinking about every single line of code simultaneously. We're thinking about abstractions. We're thinking about these simplified versions of how our code interacts with our code, just to make it easy for people to think about. A fun one that we're going to talk about later this week is inheritance, which is a way that multiple classes can share properties with each other, share features. So if we have multiple similar classes, maybe a dog class and a cat class, those are both some type of animal, for example. And so we might use inheritance to avoid repeating code between those two classes. And then lastly, this is probably the most confusing one. Polymorphism. This is the idea that objects can take different forms, or that a function can behave differently depending on the type of argument it's passed in or depending on other situations. So for example, let's say we defined a method that accepts a dog object. And then later on, we expand our program to add a cat object to our program. Maybe we would declare this method as just accepting any animal, and then it could accept animal objects and process them in some standard way. But we could write some extra code, some if statements or whatever, so it handles cat objects slightly differently than dog objects. So that would be an example of polymorphism, as we're programming in slightly different behavior depending on the type of the object passed in, whether it's, say, a cat or a dog. So this is all getting a little bit more advanced. This is going to be looking further into this week. But generally speaking, when people say, what's the point of OOP? What are the main benefits? These 4 principles, encapsulation, abstraction, inheritance, and polymorphism, these are the 4 things that people will say that they might be looking for you to say. So it's just good that you've heard this once. Okay, so that's enough theoretical, conceptual information about object-oriented programming. At this point, I would just like to show you some code, show you how we can define some classes in Python and create instances of those classes. Do people have any questions before we just dive in and start writing some code?
Is this something that's applicable to other languages in every language? Is there a method for this in every language? Like even C++, Java, JavaScript?
Every language that supports object-oriented programming supports it in basically the same way. So these basic features that I'm going to show you should exist in pretty much every programming language. They don't exactly exist in JavaScript, but we're going to pretend they do. And so don't worry about that too much. This is going to actually be more similar than you might be worried. Some languages will have more advanced OOP features. So like C#, for example, is like very much about OOP. There's no way to do anything in C# other than OOP. And it's going to have some more advanced object-oriented programming features that don't necessarily exist in all programming languages. But definitely the things I'm going to be talking about today or this week will exist in any programming language that supports OOP. But some don't support OOP at all. So like C, the original C, does not support object-oriented programming. I don't think Bash does, what we're doing at the command line. There's no OOP here. But generally any language that you're going to use to build applications, you're going to use object-oriented programming. Does that answer your question?
Yep, that works. Thanks.
Cool. Do we have other questions before we dive in?
Yeah, I have a question.
Let's hear it.
What would you call an alternative to object-oriented programming? You hear a lot about it, but what is it when you're not doing that?
That's a good question.
Isn't it something like function-oriented?
I'm glad you said that, but that's not what I would say is the correct answer. Lots of people will give that answer, and let me tell you why. So I think the first answer I should give you is that what you're all doing to begin with is procedural programming, where you're just doing one thing after another, where your code is just a list of instructions that the computer executes one after another from top to bottom. And sure, you might define a function so it jumps around to different files, but it's mostly just you giving the computer a set of instructions to do one after another. So that's procedural programming, or imperative programming, they call it. And that's kind of thought of as a beginner style. Very quickly, people will grow into something more sophisticated, more organized. Most of the programming industry has kind of settled on object-oriented programming. It's just a really it's a good like common language, I guess. Like everybody knows object-oriented programming. So if you design your apps in an OOP style, like other people will be able to read them generally and kind of understand the flow. And lots of frameworks these days have OOP built into them. So like you have to know OOP in order to use these frameworks just in a basic way. But that being said, not everything you do in your program has to be done in an object-oriented style. There will be parts that are like very OOP and then parts that are more procedural, more imperative. But so there are yet other organized styles of coding. One of those that you'll hear about is functional programming. And so functional programming is a style of writing code that relies heavily on functions. You're going to use functions that define other functions, functions that accept functions as input, functions that return functions as their output. So this relies heavily on using like map and filter and chaining those kinds of operations, and even more, yet more sophisticated things you can do with functions. But so the thing is that, in my opinion, functional programming is not, how to put this? Like you don't have to choose between object-oriented programming and functional programming. Some specific problems are very well suited to being solved with object-oriented programming. Some specific problems are very well suited to being solved with functional programming. Some problems can be solved with both object-oriented and functional programming. They're not exclusive. That's the word I was looking for, exclusive. You can do both of these at the same time. You can have methods defined in an object-oriented class that are like chained together in a functional way. So there are opportunities to do both these at the same time or in different places in the same code base. I just think of these as different tools in my toolbox that I apply, as the situation calls for it. What really frustrates me is seeing programmers who they only know object-oriented programming and they will solve every problem in an object-oriented way. Or the flip side, you also see programmers who are really big into functional programming and they think it's the greatest and best thing ever, and they will solve every problem in a functional way. Now, I do think these are very useful tools to bust out when the problem calls for it. But if you have made it your mission in life to solve every problem with a functional style, like regardless of the specifics of that problem, you're gonna have a bad time and probably frustrate the people around you, especially if I'm one of the people around you. So I just want to encourage you to like be flexible and choose the right tool for the job. So kind of to answer the original question, functional programming is another style of programming commonly that is contrasted with object-oriented programming. But I would encourage you to learn both of them. You don't have to choose one or the other. But that being said, if you only have to learn one, object-oriented programming is much more important to learn, because basically everywhere you work, they will assume that you already know object-oriented programming. It's pretty much like a requirement at this point for getting even a junior developer position. Whereas functional programming is like kind of new and trendy these days, especially in the JavaScript world. So if you're a front-end developer or doing like back-end node stuff, there's a good chance that people will be pushing a functional style on you. But that's more something that you can kind of learn on the job at the time, or just take a weekend course on beforehand. So I don't think, even though it's becoming more popular, it's not nearly as important that you're an expert at functional programming at this point than object-oriented programming. People just expect more from you in terms of OOP. Does that answer your question?
Yeah, it did. Thank you.
Well, probably a lot more than you're asking for, but it's just something that comes up a lot, and I felt obligated to talk about it. Okay. So any more questions before we dive in? Question? All right, cool. So I'm going to show you some code. I do want to say before we, actually dive into this all, this is one of those lectures that I potentially could get through very quickly. If nobody asks me any questions, we could be done here in like 40 minutes or something. But that being said, this is also one of those kinds of lectures that people will tend to ask questions about for, weeks or months afterwards, because OOP is just so fundamental. And like, if you're missing some OOP knowledge later in the course, you're going to have to go back and learn it, because we're going to be building off of this. There are some other like one-off topics that we discussed for a day or two. And then if you kind of don't get it, like it doesn't matter as much for the rest of the course. But this is definitely something you're going to be building off of for the rest of this cohort, for the rest of your career, most likely. So please, 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 if I say something that doesn't totally make sense to you, or you just want to clarify, or you want to connect it to something else you know that we've covered, please stop me and ask questions. I am hoping and expecting that there will be many questions in today's lecture. So that being said, let's make a class. So the way that we do that in Python is using the class keyword. Just say class, it's a reserved keyword, which is why we can't have variables named class. We're going to name the class. It's customary that you use title case for class names in Python. So I'm using a capital letter here, dog. And then I have a colon here because I'm like starting a block. And then inside of the class indented, I can put all of the code that defines how this class is supposed to work. For right now, it's going to do nothing. So I'm just going to put pass in there. Pass is a Python statement that does nothing. The reason why I'm doing this is because I didn't really want to write anything here, but Python demands that I put something. I can't just have an empty class. So I'm just putting this pass keyword here for now. But this is a valid class, even though it's empty and does nothing. So let's see real quick how we can create an instance of our dog class. So I create a variable, call it Fido, and assign it to dog. So dog is callable. I can put these parentheses after it and call dog. So just like we call functions, we can call a class by putting these parentheses after them. And then that's going to assign our new dog object to this variable. So let me just take a look at that guy real quick.
What's the benefit of assigning it to a variable versus just using it on its own?
I mean, how would we use it?
Can't you just write dog with the
Oh.
open and close parentheses and call it that way?
Just like,
Yeah, isn't that not the same thing?
well, where does Fido go?
You're
don't
creating a
think
different instance of the class. You're going to want several of them.
It'll make sense in a minute once. you
Oh,
actually
okay, I
do
understand. I'm sorry, I got ahead of
initiate.
myself. Yep, okay, thanks.
So let's take a look at this real quick. There's really a whole lot of nothing here, but let's see what it is. All right, so not very informative, but we can see first, there's a class, dog, and then below that, we got a dog object. So not very descriptive, but it tells us enough to know that, this is what we were expecting. We created a class, and we created an instance of that class. But so this is not very interesting, very useful. We're going to have to add some methods to this class in order to make it do anything. So you're going to define a lot of methods for your various different classes for all of the different behavior that they need to do. But definitely the starting point for every class you write is an init method. This is going to tell Python how to initialize your class, how to create new objects. So right now we just have pass, we do nothing. So Python does nothing at all when we call dog. It just returns an empty object. So let's actually make this a little more interesting. So we're going to define a function just the same way we always do in Python, except we're defining it inside of our class, and we're calling it init. And now there's one other kind of odd thing we got to do here. I'm going to declare an argument, a parameter here for this init method. We're going to call it self. So this name here, I did not choose it. This is built into Python. You don't have any flexibility. It's just the name, the method is called Dunder init. And then for reference, we say that as this is a Dunder method because it has so this method has double underscores, 2 at the front, 2 at the end. You will see that there are a variety of methods in Python that have this form. They're kind of like internal details. They're not meant to be called by us in our own code, but we define them and then Python calls them as needed, kind of under the hood, behind the scenes. There's a few of them. They're called Dunder methods. And of course, everybody always makes the office jokes whenever they're learning about Python at this point. So I'm going to spare you from those.
What's the office? I'm joking. All right.
Wait, isn't it? Am I getting my sitcoms mixed up?
No, you got it. I was just teasing.
Okay, yeah. Dunder Mifflin Paper Company. So people just can't resist that reference when I'm talking about Dunder methods in Python, and I guess neither can I. All right, so this method is how we're going to set up our dog. First, I just want to prove that it's running. I'm just going to put a print statement in there. So we see that prints out, initializing. I never actually call init, but it is called by Python when we call the class. Okay. So this is like a really important distinction here. I never call the init method myself in my code. You will never see me do something like, this is not a thing this is not a thing that you'll see me write, manually accessing the init method and then calling it like that. Except in some obscure situations, you're not going to do this. Python calls it for you. So you might notice, though, there's one weird little discrepancy between how I'm calling the class and how I'm declaring this method, which is that when I declare the method, I need to declare this self parameter, whereas when I call the class, I don't pass anything in. So in defining the method, I need to declare this self parameter, which is how we're going to refer to the object that is just about to be created, the new instance of our dog class. But I don't have to pass it in because it doesn't exist at this point, and it is created before this init method is called, and then it's available to the init method. So that just gets a little bit confusing that I have to declare this parameter that I don't actually pass in. But that's just how Python works. So now let's make this a little bit more confusing. Our dogs should have names. They should have something that makes them unique. So I'm going to add a second parameter to init for name. Now in the init method, I need to actually do something with it. So I'm going to say self.name equals name. So whatever this name parameter is that's getting passed into init, we're going to attach that to self as a property with the same name. So I could have called this anything. I could have said self.dogname equals name. I'm making a new attribute right here on line 6 and attaching it to self. Could have called it anything, but I think self.name is pretty conventional, pretty straightforward. Just going to use the same name here. Except that now I'm attaching it to self. So this dog object that we are returning will have a name attached to it. So let's see what happens if I just try running this program again. Missing one required positional argument name. So here I passed in 0 arguments to the dog class, and it wasn't expecting anything for self, so that's fine, but it was expecting something to get passed in for name. So I'm gonna have to put in Fido here. That's the name of my dog. So let's see what that gives us. All right, so we're still initializing, but the print of our dog isn't any more interesting. Just, yeah, it's a dog object. By default, printing an object in Python is not terrifically useful. Let's take a look at Fido.name, be a little more specific. So this is a small difference between JavaScript and Python. Remember, in JavaScript, we use dot notation and bracket notation pretty much interchangeably because dictionaries and objects are basically the same thing in JavaScript. Whereas in Python, those are not the same thing. For dictionaries, we use bracket notation, and for objects, we will use dot notation. So to access Fido.name, using dot notation, and that tells me Fido is his name with the capital F. Great.
Sorry, what's the difference between a dictionary and an object in Python?
The dictionary is created with curly braces. Yeah, what color Lassie is. But yeah, so that would just be a dictionary of a dog. It's, you know, not very standardized. Like I just made one random dictionary. In contrast, our class is like a factory that is a standardized way that we can make multiple dogs that will have lots of things in common, but will differ about what, you know, the things we pass in.
So is object always something that comes from calling a class?
Correct.
Okay.
So just for funsies, we're going to add a species to our dogs. So they're all going to be dog species. And this is just hard coded because it doesn't vary from one dog to the next. This is an attribute that all of our dogs will have. Jake?
Yes. Would you mind just like going over I think it's on line 18 when you say print Fido dot name, would you mind just like going over which lines like get executed when you print that?
So at this point, not a whole lot is getting executed. Like most of the code runs when I say Fido equals dog, that creates a new empty object for our dog, assigning the name Fido to that object. Then it assigns the species dog to that object, and then creates an object, assigns it this variable Fido. And so that at point, it exists as an object with the attribute name. And then if we want to see what it is, we just print it out with Fido.name. This is basically just printing out a variable that we've declared, except instead of being a freestanding variable, it is a property that is attached to an object. Francisco?
Yeah, excuse me. Just real quick, how come is it whenever you pass Fido on the print command, it also passes initializing, not just the dog name? If you're asking to print Fido.name, it's still passing initializing, even though you're specifically asking for just a name.
Because I have a bunch of print statements here. So inside of the init method, I put a print statement. And so this runs just when I call Fido equals dog. So I can take out this print and this print. And we still see initializing because this method, Dunder init, this runs every time we call the dog class.
I see. So as long as, even if you're calling something specific inside of the dog class, if there's a print method outside of that specific thing that you're asking for, it's still going to print it out.
Yeah, at the time that we instantiate the object. So on line 13, we'll see it then.
Okay.
Normally, yeah, normally you wouldn't be putting print statements inside of an initializer though. I just wanted to let you know when this runs. Because that's going to be a theme that comes up. We're going to have to define functions for our applications that we do not call themselves. The code will call it for us. And so it'll be an interesting question, you know, when does this code actually run? And one way you can investigate that is by putting print statements in and seeing when they pop up. We got a couple of hands up. Who's got some questions?
Yeah, I have a question. Beat Skylar to it. So you assigned dog Fido to Fido, which gave it a variable, but then when you did Fido dot, whatever, and you call another function within your class, every time you use that variable, is it having to run that init within the class every time to redefine and reorganize the data, or is it
Nope.
saved in Fido that way?
Yeah, so this function only runs once when I call dog.
Okay.
And then,
so Fido contains that object of information now.
yeah, the self that we're adding properties to here, this is what gets returned from init. I know there's no return statement here, but this self gets returned and then we are assigning it to this variable Fido.
Okay.
So at this point, it's very similar to a dictionary. Honestly, it's one variable that's storing references to other variables.
It's an object with built-in methods. Okay.
Yeah, we'll get to the methods in a second.
Sorry. All right. Thanks.
Yep. What other questions do we have? So Skylar?
Yeah, to kind of piggyback on what Francisco was saying, like on line 18, just because you call the Fido name, that doesn't call the print at all in that print initializing, just Fido name, right?
Right. And
okay.
So to be clear about the terminology, I would say that on line 18, I am not calling Fido name. Calling means specifically that you are invoking a function or something else that is callable and putting parentheses after it. It's really these parentheses that make something a call. So like on line 13, I am calling the dog class to assign to Fido. And on line 18, I'm calling print in order to see what the name property of Fido is. but I'm not calling Fido here. I'm not calling Fido.name. I'm just accessing this property on an object, or I'm referring to it, you could say. Nathan?
On that note, just to see it, can you like print out everything that's included inside of that object in Python? Like I tried to just print Fido, and the only thing it did was return or print, sorry, Fido. It didn't do dog. Why is it only doing the name, for example, and not doing every single thing inside of it?
So first of all, if I just say print Fido, should tell me almost nothing, just that it is a dog. And this is the address in memory, but I don't really know how to do anything useful with that. So this is, I'd say, one recurring frustration that some people have with Python is that the default behavior for printing an object is not very useful, but also by default, almost everything is an object. And if you're trying to print like numbers or strings, those have more useful default printing behaviors. But for like the more complex objects, especially ones that we define ourselves, the default printing behavior is not super useful. So at this point, I'm gonna actually skip ahead a little bit and show you one way that we can address this issue. So I'm going to define another Dunder method on my dog class. So every object can optionally have a Dunder string method. And so what this does is when Python is asked to represent an object as a string, it's going to call its Dunder string method and then just use whatever is returned from there. If it doesn't have a Dunder string method, then it just uses the default string printing behavior, what we see down here, which is not particularly useful. So if we want to replace this, I'm just going to define my own method, Dunder string, and I'm going to say return So like all of the methods on our in our class, we must declare self as the first parameter. Now note that you don't have to call this self. This is just a convention. And in theory, I could have named this parameter anything I wanted. I could have said me, because it's just a function parameter. And so as long as I'm consistent, it's going to work. But that being said, even though this is just a convention, this is a very strong convention. This is like the strongest convention in Python or any programming language. I have never seen a class defined in Python where any other variable name other than self was used for this parameter, how the object refers to itself. So if you try to get cute and creative and choose any other variable name, and then ask someone to review your code, it's going to look bizarre to them, and they're going to be kind of turned off things that you don't really know, like what the programming community is about, or like you've never seen anyone else's Python code before. This is just such a strong convention. I've never seen it any other way. Okay, but so also I'm using the self parameter to access other properties on this object. So I know from reading the init method that all of my dogs have a name and they have a species. So I can just trust that those properties exist here when I try to print them out in this F string. So now when I print Fido down here, we get a slightly more useful output in our terminal. It tells me I am a dog named Fido, just using this sentence here that I've hard coded with these variables interpolated into it. Sound good? Everybody kind of understand, the Dunder methods, how I never called this myself. I just define it, and then Python calls it for me as needed. Skylar, do you have a question?
Yeah, sorry. Does that only work when you print the actual class, or can you use that Dunder string to potentially concatenate additional strings when inquiring the object class?
So let's see. I'm not sure, but okay, no, it's not going to do that. So I was wondering if it would just automatically convert Fido into a string. And it seems like it won't do that. So, I mean, you can do something like that, I think. And
Well, I think that doesn't string only respond to print.
I mean, you can only print, well,
You
you can
can't
only
like,
print strings. And if you try to print something that's not a string, it will convert it to a string in order to print it. And I think how that happens under the hood is that print will actually use the str method. But yeah, concatenation is not going to automatically convert the types. Just print does that to be useful. But yeah, we can see here that when I call string on Fido, that does not throw an error. It's just converting it into this string here. And then we just concatenate 2 exclamation marks onto the end of it. Alicia, did you have a question?
Yeah, I'm wondering, why did you have to put string in front of it when your Dunder method above already returns a string?
So the Dunder method above means that,
Oh, wait, you're not even printing Fido necessarily. Okay.
yeah, so what I had before, Fido plus bang bang. Here I'm not explicitly converting Fido into a string. I'm trying to concatenate this object into, trying to concatenate an object with a string, which is illegal in Python, so that's going to throw an error. Now, what I've done up here is defined the possibility for this object to be converted into a string. So if we need to do that, this is how it's done. But still, Python is very hesitant to do that automatically. Even though I've declared how it can be done, Python still doesn't want to do it unless I'm very specific, like this is what we're doing. So either I can call the Dunder string method myself, or I'm sorry, if I use the built-in like str in Python, that will use the object's Dunder string method if it has one, or print will use the object's Dunder string method if it has one. But I guess for the plus operator, it's not going to go looking for a Dunder string method. It's going to assume that I made a mistake if I try to add an object to a string, and it's going to force me to just be more explicit about what I want.
Okay, thanks.
What other questions do we have? There are some other hands up. No? All right. Sorry, I was looking away. Did someone just raise their hand?
Yeah, I'm still trying to wrap my head around this. Can you just like show me where you're actually naming the dog Fido?
When I call dog,
Mhm.
and I pass in one argument to this call, it's just the string Fido. So
Why is that not like go into the self or parameter though?
So that is a really good question. That is a question that pretty much every Python developer has asked themselves at some point. It's a question that I continue to ask myself, honestly. And this is one of the more awkward parts of Python. I'd say like Python is a very simple and elegant language until you start getting to object-oriented programming. You'll start to see some things that are a little bit awkward, and you might think like, hey, you know, Java does this better, C# does this better, or whatever. So it's good that you point this out. This is something that a lot of Python developers don't like. That's kind of awkward. That because there's this extra method self that we have to declare in our methods, but we don't actually pass in when we call the function, that means all of our arguments in our constructor are offset by 1. So here, Fido is the only argument we pass in, but in the definition, it's actually the second thing we declared because self has to go first. So I'm going to expand on this a little bit. Let's add some other properties here. So let's say dogs can have different colors. And they can have sounds. You know, some of them are little yippy yappers. Some have a deep, bassy kind of woof to them. Okay, so now there's 4 parameters defined in init: self, name, color, sound. So when I call my dog constructor, I need to pass in order, name, color, and sound. So these have to match name, color, sound, match what I'm passing in, Fido, brown, woof, but it does get confusing because I did have to declare self as a parameter, and that just pushes everything forward 1. So Fido, brown, woof, these are actually the second, third, and fourth parameters when I defined my init method, because self must go first and it pushes everything forwards. Does that help?
Yeah, that definitely helps. It's still a little confusing. I gotta think on it for a bit, but it helps. Thank you.
Definitely is a little bit confusing. This is like one of the first things that everyone gets tripped up on when they learn OOP in Python. So totally understandable. We have some other hands up.
I was gonna say, so would it be wrong to say that, like, so when you're in line 18 where it says like Fido equals, you know, like your instance variable or instance object, would it be wrong to say that the actual instance object of Fido would be what you pass in as self?
I'm not sure if I understand your question. I
So, like,
would say that Fido is an instance of the dog class.
yeah, so when you say like for your initiate your Dunder init where it says self, name, color, sound, would Fido kind of be like, to think about it, like self would just be the actual instance of the object?
Yeah. Self is the actual instance of the object. So everything that gets assigned to this variable here, Fido, that's that self here. I'm just attaching a whole bunch of properties to it, and then it does get returned. You never actually have to return it, but you should understand that that happens implicitly, automatically. This self object gets returned, and whatever properties we put on it, they are accessible on this Fido object that we returned from the dog class.
All right, thank you.
I got a lot of hands up, loving all the questions, but I don't know who's who, so let's just shout it out.
So can we do the same kind of like how I think it was with functions, do the default parameters? And also can you like when you're trying to define that, like Fido equals dog, can I put like color equals blah or like that kind of thing? So it can be out of order. We can just choose one thing to add into it.
Yeah, you can do stuff like that. So like I was saying before, in many ways, this is just a typical Python function. And so all of the usual complexities of Python functions can be used here as well. So you can mix, positional arguments with keyword arguments. You can use star args or star quargs for an unspecified number of arguments. I usually try to keep things simple when I'm defining my OOP classes. I want to make it as easy as possible to understand how are these objects being created. I don't want people to feel like they need to debug the init method. Ideally, this should be like as simple as possible. You're just assigning properties to an object. But yeah, you can do all that good stuff. So if we look at Fido.sound, he says bork bork. So the default would have been woof. So I guess now that we've actually set a default, we don't even need to pass in sound. And he'll just use the default value of woof. Does that answer your question?
Yes. Also, just on that same note, if the order is there and we don't call something, if it's just not put in, like we don't call that parameter, what would it do exactly? Just to be sure.
So if we like omitted sound, or like if color was a
Like
name.
if we had no defaults and we only put in like 2 parameters and there were 3 that were supposed to be defined there.
That's going to be an error. So Fido. Okay, so yeah, we forget about self. We don't actually pass that in, but we do need name, color, sound. Here I'm calling Fido, calling the dog class, passing in only 2 arguments. So these would be used for name and color, but there's nothing for sound. So I'm expecting that Python's going to throw an error saying that I don't have enough arguments. So that's what we get. We are missing 1 required positional argument, sound. What questions do we have?
So when I don't know if I just missed it, when you put the default value for sound, why did you have to, when you called it on line 19, did you have to put sound? Couldn't you just type in the string, or would it not work that way?
If I declare it as a keyword argument up here, it must be a keyword argument when I call it. So if I say sound equals woof, but then I pass it in as positional argument, pretty sure that this is going to crash. And okay, actually that is not what I was expecting. So it looks like I declared this as a keyword argument, and then I didn't actually use sound equals anything. I just passed in the value I wanted, but because it was still in the right position, I guess Python figured it out. So it's not what I was expecting. Usually Python is more particular about things like this. Generally speaking, I'll say that if you want to mix positional arguments and keyword arguments, the keyword arguments have to go at the end. So that way it's less confusing which ones are positional, which ones are keyword arguments.
Is keyword argument just another term for like a default value?
Yeah, when you use the equals sign like that in the arguments, so that I can declare it like this when I call the class or call the function. Just because here when I pass in the argument, I'm using the keyword sound instead of let it be assumed that this is the sound based on the position.
Now, since you're doing that, could you technically put sound at the very beginning? Or would that not work?
I'm pretty sure this is going to blow up.
Okay.
Yeah, my editor is already yelling at me before I even like try to run the code. Yeah, positional argument follows keyword argument. So you just can't do that. What other questions do we have?
If you want to change any of those parameters, like later on without like recalling your class, would you just do Fido dot and then whatever you want to change to like update it later on? Say like Fido changed his name, or not his name, like changed his color or something like that. We do Fido dot color equals and then whatever new color, and would that update your class?
Yeah. So let's say his original color is golden, but then he plays in the mud. So we'll say Fido.color equals brown. So he is a brown dog named Fido. but only because he was playing in the dirt. Had he not been playing in the dirt, he would be a golden dog named Fido. So yeah,
Okay.
you can totally reassign properties after you create them. This is just a starting point, but after that, there are objects very similar to dictionaries, and we can update their properties as things change.
Could you even like skip the call? I mean, I probably wouldn't, or like there's no real reason to do it, but like, can you just kind of hard code them all in, going like Fido.color, Fido.name, Fido dot whatever? Or do you have to like call it one time at least, initialize it first before you start manipulating anything?
You mean like right here, add all those properties?
Or even before you did like the Fido equals dog? Like, I'm guessing you do have to initialize it every time. Like you create a new variable for your class, you have to initialize it. I think I was just getting confused with something else, but yeah, you answered my question. Thank you.
Okay, because I'm not 100% sure if I understood where you're going with that. Because if you want to change the definition of dogs, how all dogs work, then you would update the class. But if there's just a single dog that has changed itself and that doesn't have any bearing on all of your dogs, then you would assign a property to the individual dog.
Okay, cool.
So this is really the most important, most fundamental distinction to be clear on in object-oriented programming is the difference between a class and an instance of the class. That I know I said it before, but this is the most important thing to be clear on, and people do get confused on it, that your class is just a blueprint, or it's like a factory that creates some other thing, many instances of some other thing. So my dog class is not a dog in itself, but it's a factory that creates more dogs.
Okay.
And so this is kind of the definition of what a single dog would look like. The other methods, we'll see more of them, are going to define the things that dogs can do. But dog is not an individual dog. Fido is an individual dog or an instance of the dog class.
Yep.
Please note my capital letters. This is an important buzzword. It's how we talk about the things that come out of our class constructors. They are instances.
So I have a couple of questions. I'll start with my one that I think would be most applicable. So I know that when you want to change something to a class later on, you could do, for example, dog.vaccinated equals true, right? And then through inheritance, any dog instance that you've already made will inherently get that same thing if you were to try and print that. So I know that, but my question is, what if later on for like, you know, something is changing? It would be really good if every time we make a dog, it also had this initiation attribute. How would you update the attributes that you wanted to add for any future dogs? And then would you then need to provide a default value for any past dogs that have already been made so that it doesn't ruin any past code? Does that make sense?
Sure. So it depends on where these dogs live and how long they're living for. So if I'm just making these dogs like as part of some algorithmic challenge, like the sorts of homework that I might assign you, like those dogs only need to live for the duration that the program is running. And then every time I execute that script again, it's, you know, creating a new set of dogs and applying the same logic or operations to them or whatever. So in that case, like I would just update my constructor to just have whatever it is all of my dogs need to have. So that way the next time I run my program, you know, we clear the memory and it creates a new set of dogs. And then all those new dogs that are created are going to have this newly defined logic. But I think maybe what you were getting at was more of the situation where I have, you know, this class that's creating dog objects, and then I'm saving them somewhere permanently, like in a database.
Yeah, so let's say it's like a dog adoption website and you've got 10 dogs on the site with that data, but then you recognize, oh, well, all my users also want to know if they're already up to date on their vaccinations. So I want to do that.
So that becomes a more complicated problem. But in that case, you would start at the database, saying like, okay, we have to keep track of vaccinations for these dogs. So you would update your database and how you keep track of the dogs there to accommodate that extra field for vaccination status. And then given that, you would have to update your model here, your class for self dot vaccination. It's false. We're just going to assume that they're not vaccinated until they get vaccinated. Or, let's just say that doesn't make sense. So that should be a parameter that gets passed in. So yeah, then we would have to first update the database and then update our class here to accommodate, to kind of mirror that change to the database. Because we're probably going to fetch a whole bunch of dogs from our database and then immediately create a bunch of dog objects for them to accommodate that. So that's how we would accommodate that change. But that wouldn't take place until the server restarts. So okay. I think maybe what you were concerned about is not a problem, which is if you already have like a bunch of dog objects in memory, like you got 1,000, Fido, Lassie, whatever dog objects sitting in memory, and then you say, oh shoot, I need to record their vaccination status. You're not going to have to update all of those objects in memory in a currently running program. You would update the database, update your class, and then restart the server.
Oh, okay. Got it. Okay. Thank you for that. And then my second question is, well, first I want to ask if this question, if you even should be answering this question. So is there, how often would you like the, later on in the example you get to with the fetch, right? Because you said the Dunder string method allows you to just say print Fido, for example, and it returns that. And you did the example of how you set a variable to the string Fido, and then you could then concatenate with that another string. So then I was wondering, well, can you do that with the results of another method? So it's again a two-part question. My first part is, how often do you need to take the results of a method and then say concatenate that into a string, and how would you do that?
If I need to take the results of some method and then concatenate it to another string, probably just use the str method in Python.
So I tried that and I think I must have been doing it wrong.
Shouldn't be too tricky. Maybe we can take a look at it offline sometime.
Okay.
What other questions do we have?
Go ahead, Dalton.
Cool. So just kind of to piggyback off her question, because it kind of confuses me, especially with that, like that kind of adoption kind of scenario you just brought up. So how long, when you build like a web application, how long does the script pull from memory first, or are you building it? I don't even know if that's the right way of wording it, but I guess really what I'm trying to ask is, how long should you be planning for the script to like run, if that makes sense? Do you know what I mean by that?
Yeah. So, I mean, if you're talking about a web application, that's basically a script that's stuck in a while loop. Just it never ends, and it's constantly listening for people to send requests and then waiting until someone does, and then it springs into action and does what it's supposed to. But like a lot of your individual functions will run and then complete, and then throw out whatever memory they created during that execution. So, I mean, some of it's permanent, some of it's temporary.
Okay. Thank you.
Yep. What other questions do we have?
Raphael. So on line 20, see how when you're calling the dog class, you're passing in all those arguments.
Yep.
And if you don't pass in those arguments, then it complains.
Right.
Are you able to like overload the init method so that way you'll be able to call the dog class without passing in those arguments?
So that
Like have a default like init method with no parameters.
yeah, I mean, we could do like, I mean, for one thing, you could just have default parameters for all of these. We could also just set none as the default. So the user can pass in values and you'll use them. Or if they pass in none, then they pass in nothing, but at least Python was prepared for it. So let's say ghost is a dog. Print ghost. So yeah, he's a none canine named none. It does create a dog object. And it has the method Dunder string. So it looked like that worked. So yeah, I guess if you wanted to make some of the parameters optional, you could do that. And this is kind of a way of overloading it. You can say, you know, there's a form of init if they do have a color or if they don't have a color. So I might say like with color, and do that stuff. Else do something else if they don't pass in color. So I could do things like that. Potentially initialize the dog differently, depending on which arguments are or are not passed in. I don't do that too commonly though. What other questions do we have? Could have sworn I saw some more hands up. All right, so that was a lot of great discussion, a lot of great questions. The next thing that I have to show you is how we can define instance methods for our class. But we've been chatting for a while here, so I think this would be a good time to take a break. So let me just double check real quick. No one has any more questions about just the basics of OOP or attaching properties or attributes to these objects? Anything to talk about before we get into instance methods? Any last minute questions?
So the only way to update the class is to go into the Dunder methods themselves, correct? In terms of like defining additional variables.
Yeah. So if I wanted to, you know, have like, you know, when I added the vaccination status, it's just another thing I added to the init. So more attributes or more things that your instances know, you put that in init. And then for other things that they can do, other methods, we're going to define other methods here using def. We'll see that after the break.
Okay, thank you.
Yep. Any other questions? All right, so it's a little after 10:45. So let's come back at 11, and I'm going to show you all how to define methods on a class in Python. See you soon. All right. So when we had left off, we just finished covering instance attributes in Python OOP. So next, and the last thing we need to talk about this morning are instance methods, the things that our class can do. So right now I've defined a whole bunch of attributes, things that we know about our dogs, adjectives, let's say, but we need to define some verbs. So our dogs should be able to bark. They should be able to make some sounds. We've defined what they sound like, but I would like to actually let them bark, something that we can call that makes them do a thing. So I'm going to def, and call it speak. So all our methods take self at a minimum, and a colon, and now we will print All right, so now I've defined this functionality, speak, that because it's defined as part of our dog class, all of our dogs have this ability. They can take their sound that we've defined for them and format it into this sentence that kind of looks like, dialogue, like someone is saying something. It's got this little caret, I guess. And then we can call it on one of our dogs. Comment that out. Speak. We'll call that with some parentheses. All right, forgot the vaccination status. It's actually, oops. Get out of there. Great. So now when we speak, it takes their sound and then interpolates it into this string. So it's formatted in a very particular way. Not super interesting, but we did give our dog something kind of unique they can do. I saw one hand up. What question do we have?
Yeah, that was me. I was just curious about the double caret, if that was like a particular syntax or anything, but I see in the print, it's just a way of kind of.
Yeah, not
indicating
particular
the sign.
syntax at all. Just trying to indicate let's see. Something like that. Just string formatting, nothing special about it. Okay. Now let's take this a step further. I'm going to define a method that takes an argument. We're going to define a fetch method. This is going to be only slightly more interesting. Still going to be just kind of printing out some strings, but at least this one is going to let us specify what we're fetching. So now we can pass in an item, and then our dog will say, will identify themselves and say that they have fetched the item. So we've got Fido as a dog. We can Fido.speak. Let's say Fido.fetch bones. Why not? That's a thing that dogs fetch, right? So let's see what that looks like. So calling fetch on our Fido object, this fetch method on our Fido object, passing in bones to this function call, returns this. Well, it prints this to the console. Fido fetch the bones. because one of these variables that we're interpolating, this just comes from self. So this is on the object itself. And then the other string that we're interpolating is the item, which was passed into the method itself. So this is pretty similar to how we define functions in other cases, except that we also have access to self and any other property that was defined in the initializer or the constructor. So this is kind of like the core of object-oriented programming, is using classes to create instances of those class that can perform methods that they're able to do things with respect to what they know. So it's not that every dog is doing the exact same thing the same way, but they're doing it with respect to themselves, using their own name or their own color or whatever. We have a few hands up. Danielle, what's on your mind?
Yeah, can a method call another method?
Sure, why not?
Like I don't know, speak louder, call the method speak for some reason. And what would be the syntax of that?
Let's try this a little bit differently. Okay, so now speak, instead of printing itself, it's going to just return the data. So here we'd have to print Fido.speak. Okay, Fido says bork bork, great. Because Fido.speak no longer prints anything, it just returns a string. So we're going to pass it into print to actually print it out. So your question is how we can have a function, a method that calls another method.
Right, within the same class.
So let's say speak. Yes. So something like that. Within the class, we can refer to other attributes or methods in the class using self. Just anything that is attached to our dog object, we can refer to it with self. So most obviously, these attributes are attached to self, and we can refer to them as self.species, self.name. But these methods, speak, yell, fetch, whatever, these are also methods on self. And so one of these methods can easily refer to another. So we've got speak, which just prints out your self.sound, well, returns self.sound, but it's all lowercase. Maybe your dog is like extra excited, so you want it to yell, but we don't have to, redefine this whole logic here, because it's really just one modification of another method. So we'll call self.speak, get that value that it returns, and then call upper on that, which will capitalize it. And we get our yelling dog down here. Great question.
Thanks.
What other questions do we have? So I should say that this is literally all the content that I have for you today. Like the rest of this morning is just for you to ask questions about OOP, because I know you're going to have questions about OOP. So if you've been waiting to ask a question this morning, now's the time for it. Dalton?
So not really a question, but just kind of clarification. So the Fido is an object of the dog class, correct?
More precisely, I would say Fido is an instance of the dog class.
Thank you.
Yep. There was another hand up.
Yeah. So as far as creating more of the objects, so let's say we get a problem that says create a series of classes, or not classes, but for example, class dog, to create a series of different classes with the same name dog, is the problem basically asking us to find a way to create a function that will create the class, or are we supposed to call something within the class to create the class multiple times? Or are we just simply doing like the example fido equals dog and then putting all the inputs in there manually?
So I'm not sure if I understand you correctly, but generally you're not going to be like using functions that create classes. You know, I'm going to handwrite this class by myself, this class dog. I wouldn't like create multiple similar dog classes. Once I've got my one dog class, you know, I can make as many dogs as I want. You know, Fido is all that, Lassie, another dog. She's even more golden than Fido. So I create multiple dog instances from the same class, but I'm not going to be creating tons of different classes unless I have, you know, different types of dogs, different types of animals I need to create. There's different types of things that I'm going to create many instances of.
Okay. And then the other question that I have is at any point, are we ever going to have to like sort through one of these classes and like make sure that these things end up in a different order and not sorted by their keys, but rather sorted by sorted by the keys, not by the item? Or in reference, is it always going to be like an item process whenever we do anything as far as sorting, if we do sorting?
You're not going to be worried about sorting the objects. If the properties are like on the object in a particular order, you don't really care what that is. Because you're never going to be like looping through an object and just printing out all the properties. It's more that you know there's a specific property on the object that you need and you're going to access it directly. Like I'm directly accessing the name and sound because I need them for speak. The yell method is directly accessing the speak method because it's needed there. You're not really going to be sorting or looping through objects very often. You basically treat them as being unsorted, and that's fine. That's what we expect.
Okay, thank you.
Yep. Pretty similar to how dictionaries are, or at least they used to be unsorted, and I still think of them as being unsorted. Just the order of keys in a dictionary is usually not relevant, and you'll have more robust code if you write your code such that the order of the keys doesn't matter. What other hands do we have up? What other questions do we got?
So is this what we just did by defining it inside of itself like that, or like setting it up to be the class? Is that what you're talking about with encapsulation? Like it's only requested whenever we try to make a new dog, for example, in this case or something like that, and that's what's kind of keeping it away from having to be repeated?
I mean, in a sense, this is like a form of encapsulation, I guess, because like, well, let me think about this. No, at this point, nothing is really encapsulated because all of these methods, all these attributes and methods, these are publicly available on the dog. So everything I've defined here, any other part of our code can access it. So after I've created the dog object, you know, from outside of the class here, I can just print Fido, speak, yell, fetch, or just access the individual properties.
So how would we make that not the case, that it's actually encapsulated and it's not like accessible or whatever?
So you can define private methods. I'm actually not sure offhand what the syntax is for that in Python. Apparently someone's complaining that they're not actually private methods or whatever. Wait, this is not what I was looking for. Maybe Python is a bad example for this. There's like a convention in Python that private methods have a double underscore in front of them, but I think that that doesn't actually prevent other parts of your code from accessing them. It's just kind of a convention that other programmers look at and say like, oh, this was intended to be private. I'm not going to use this method from outside the class. But in other programming languages, there is actually a way to define methods as being private. So for example, if Python was a language that supported this, I would potentially be able to say like, speak is a private method, which means that yell can access it because yell is inside of this class. You know, we're inside of this class definition. It's all indented under dog. So in that case, yell will be able to access speak because speak is private to this class, but yell is also defined inside the class. But then that would mean that outside of the class, we would not be able to call fido.speak because that would be private detail, not a public detail we can access from outside like this, whereas yell would be publicly available. So yeah, there's this concept of private methods and private attributes that you can only access from within the class. I guess Python doesn't actually have a native way of enforcing that. It's just kind of a convention that people do. If you see something with 2 underscores in front of it, then that's intended to be used internally. And so please don't call that outside of the class.
There's nothing actually barring you from it.
I believe that's correct, yeah. Which is a little odd. Apparently some people don't like that very much. What other questions do we have?
Can a class call another class? And is there ever a situation where that will be necessary?
Yeah, you could totally do it. So, you know, we've got our dog class here. Let's say we had another class for person. So people have names, but also people have dogs. Oh, I forgot I'm writing Python here. And so then I could say Alice equals person, name is Alice, and her dog is Fido. Or I'm sorry, you were asking if one class could call another class?
Correct, yes.
Okay, so we're not going to pass in a dog object, we're just going to pass in a dog name. I don't know, what's a good name for a dog?
Boney.
Max.
I like Boney. So yeah, just the same way I could call dog outside of this class, wherever. Because it's just defined here outside, you know, the top of the file, I can access the dog class from anything that's defined later on. So in my person class, we're just going to take that dog name and feed that into the dog constructor. I guess that's also going to need a color and a sound. All right, so these were from the previous logs, but we can see here that we've printed out a person object. And then when we print alice.dog, we get I'm a black canine named Boney, because this dog is an instance of our dog class defined up here, which when we print, it's going to use its Dunder string method so that Python knows how to represent this object as a string. Sound good?
Can you scroll back down so we can see that again? Down. Yeah, right there.
So is that something that happens in real world scenarios, like calling a class from another class?
I could potentially. I'm struggling to come up with an example of when you would do that because honestly, practically speaking, you don't use object-oriented programming like the way I'm going to show it to you in these demos. Like you're not going to be building web applications that have dogs and cats and like cars and shapes and stuff like that. These are just like really good for explanations. More commonly, like classes will be provided to you by tools that you're using, and you just have to understand how they work, how OOP works, because that's like the metaphor that everything is described in is OOP. So like the real answer is like practically, I don't even define my own classes that often. Like they're given to me and I just have to work with them. So like I don't really, call one class from another class just because I don't like define my own classes too often, but you totally could do that. If the problem called for it, you've just got one type of thing and each of those things has some other type of thing that it owns or refers to, then yeah, it could totally make sense to call one class constructor in another class's constructor.
All right, thank you.
Yep. What other questions do we have?
So I don't know if this is getting too far into the weeds, but I'm kind of trying to just understand like how this would work practically. So like with C#, it's like you have a scene and you have a bunch of different classes and they all load whichever scene you're in. So when it comes to like doing stuff like this, like, are you only going to have one main script, or is it going to be like a bunch of different scripts that do different things depending on what you're doing at the time?
I mean, it depends how you look at it. Like you have one application, which is, one program with a whole bunch of scripts kind of doing things together. But like also you would have multiple classes generally defined in multiple different files. Commonly you'll have one class defined per file, and then you import them into the other files as needed.
So there's like one main file and you're going to use other files depending on what you need to do?
Yeah.
Okay.
I'd say like in any program, there's always one like main file or one main method, just one thing that has to start off everything else. So you might have noticed I'm always creating a main.py or a main.js file. And our applications are going to get much bigger and more complex, but it's still going to be the case that there is a single file that like starts everything off. It's called the entry point. Actually, why don't I just show you this real quick for fun? So this is jumping ahead a little bit, but when we get to using NPM more, we're going to create these package.json files in order to record our dependencies. We've already seen one. And then the way you create that is with npm init. Now these files have a lot of other information in them beyond our dependencies that can be useful. And so you can see here, this is just the default package.json with all of the default settings. I haven't actually edited or changed anything, but it has this field here called main, and it defaults to index.js, which is not correct in this case because I don't have a file called index.js. But in theory, this is supposed to be your starting point, or your entry point is what they call it. Just the first file that you run to start all the other files in the application. So when you open up a big project, it might not be obvious at first, like what's the first file that you run in order to actually start this project. Hopefully it's a main.js that's right at the root of the project, easy to find, but sometimes it's going to be buried like several folders deep, and it's not really obvious how you actually run the code. So one way people get around that is in the package.json file, you can specify the main file, which should be the one file that you actually run in order to start the application. So yeah, there's always an entry point, one file that starts things off and then pulls in the other files as needed. We don't really need this, so I'm going to delete it real quick. What other questions do we have?
I had a question regarding, what was it? So within the class, we have, multiple functions essentially. So if we want to have a variable that we need to pass between functions, where would we do that? Do we just define a new self dot something as a variable we can pass around, since that's the object we're passing around, or would we pass it around through the inputs of the functions and return them? You know what I mean? Like if I need to make a count in one and then call it in another, or refer to it in another.
So
are these
is
global?
this like some piece of information that the dog would know, like how many times it's barked or something?
I don't have an example for this particular scenario, but I suppose, yeah. But I guess, you're making it clear that it's best to have any passing variables saved as just an extra object identity, which makes sense since you're already passing that list of variables around. So
yeah, there aren't really many other ways to share data.
Right.
So I could define something outside the class, foo equals 10, whatever. But you probably want to keep everything contained as much as possible. If there's a piece of information that belongs to the dog itself, you can stick it on self. So, I've said self.barks equals 0. And then every time he speaks, I'm going to increment that by 1. And then maybe I would do something else with the number, like limit him to only 10 barks a day or whatever.
Sure.
But if there is information that only needs to exist in your init method, you can just define local variables here. So like, what if instead of name, they passed in first name and last name, but I only want to have name in my actual object. I could say equals first name, Ellen equals last name, self.name. Equals plus. So this is pretty verbose. I could have done this in 1 line of code instead of 3. But my point is just that you can still create local variables in this init method. If you just need to keep track of something very briefly just to compute something else, totally you can make local variables. But only the things you assign to self will actually be part of the instance.
Okay. Follow-up question. Is it better to have your internal functions returning, like in most cases you have them returning a string, but in one case you have it directly printing. So if they were to type, print dog.fetch, would that confuse the system? Does that make a difference? Because they have to do print dog.yell or fido.yell, you know what I mean?
Just for this like real simple example, we actually printed directly in the methods to just get some output on the screen more easily. But more commonly, more practically, you're not going to be printing from in these methods. You're just going to calculate what the value should be and return it. And then the code that calls this method gets to decide what to do with that.
Okay, fair enough. That's it. Thanks.
Cool. What other questions do we have? Robert?
Yes, I was going to ask you, if we are, let's say we're updating the information of the dog, we're changing the name, the color, and everything else. Is there a way that we can print all the instance attributes at once, or do we have to print them one by one?
There isn't a super elegant way that I can think of to print all of the attributes one by one. There probably is a way, but I would think to just define a Dunder string method that prints out all the attributes you care about. So, this could just be like, So I don't know, this is not super like smart, but it works. All right, this has to be an F string. Cool. So there I just kind of improvised a print all the properties method for my class. Just because Python doesn't want to assume which properties I want to see and in what order and how we should format them. So it just doesn't even try. But without too much effort, I was able to get this printing things out. Hope that helps.
Yep, thank you.
All right, what other questions have we got? No other questions? Going once, going twice.
All right. Bye. So you talked about polymorphism. So would an example of this be in our dog class here, where we made an instance called Fido and he barked, and then we made an instance called Boney and he woofed or something. So when you call the print method, and they each do their own sound or bark, or yeah, their own sound, is that an instance of polymorphism? Or is that like really simple and polymorphism is more complex than that?
Yeah, I'd say polymorphism is more complex. It's really treating both these objects kind of the same way. It's just a different literal string that it printed out at the end. It's a lot easier to talk about polymorphism when we get to inheritance, and we're going to have like different types of objects working together in the same class. I'd say like if you saw, like if there were just two entirely different functions that ran depending on what object was passed in, that would be polymorphism. Or like if there was, you know, an if statement at the front, at the top of the function, and so it did two entirely different things based on the type of the input, you might consider that polymorphism as well. But it's kind of hard to point to a good example before we've gotten to inheritance. So hold that thought. We'll come back to that later this week.
All right, thanks. So one more thing, when you're talking about objects, are you talking about, is that the same thing as talking about instances, or does it also pertain to classes? Is it more of a general term?
Yeah, all objects in Python are instances of a class. Does that answer your question?
Yes, it does. Thanks.
What other questions have we got?
Can you scroll up just a little bit to where you showed how you would print them all out together?
So yeah, it's pretty simple. It's just a string, but I use the triple quotes, so it can be a multi-line string. And then an F string lets me interpolate variables into it. And then these are just all the properties from self that I wanted to see. Because this is a method defined in the class, self is always accessible as the first argument. And yeah, I can use that to print anything I want. All right, what other questions have we got? No more questions. All right. So if there are no more questions for this morning, I think this is a good time to conclude our lecture. It's a couple minutes early, so it's perfect.